maybe sometimes you struggle from the words. طيب. Second thing, we now, yes, for fluid 2. In fluid 1, as an example, you study that there are 3 states of matter, which are solids, liquids, yes, and gases. I want to make sure that you are good in these. All of these. First of all, in case of solids, we want to talk about the pressure. Pressure is coming from a force. This force, we call it by a normal or perpendicular force. Just like, for example, if I push the chair like this is not a pressure force. This is displacement force. أزحته. When I step on it, لما أصعد فوقه, at that time, this is pressure force. So my force, which is my weight in this case, is nothing but the perpendicular force. Is that right? Can I say also, this table, I will never break it if I step beside it. But I'll break it if I step on it. Right? ما حد يا شباب بيكسر طاولة هو واقف جنبها. بيكسرها لما يصعد. Right. So this is first of all. I mean, if we have an object, this object, and we apply a force in it. This is the force. We say simply the pressure is equal to force over area. And we know these simple things. I'm going to show you something here. Now this pressure, in case of solids, is directed downward. Only. There is no side pressures. Now this is in case of solids. If we go to the liquids, you know liquids, they always kept in a container because they have no definite shape, right? So if we put some water in a container like that, we will see that there are just 2 types of pressures. There is downward pressure at the bottom, and there is also side pressures. So here we have only downward pressure. Here we have down and side pressures. Okay? Now, you know also the formula for it. We studied that the formula, which is derived from here, by the way, for liquids only, I will write for liquid is equal to rho G H. Now, this is rho stands for, tell me, you studied this, it's density.
Yes.
كثافة. And this is H, stands for
Height.
height. Let me explain this. Of liquid column. I'll explain, or depth. Let me explain this a little bit. Pressure of liquid depends on density. More dense liquids have more pressure. If you carry 1 liter of water, it's different than 1 liter of mercury, liquid mercury. Because mercury is too much denser than water. Okay? Now, the second thing, gentlemen, we have the height. When we say, for example, see, if you have a container, this container contains some liquid. If you assume that, what about this point A? Point A, the height is this one only, above of it. If we say point B, oh, the point B, the height is different. And according to that, we say the pressure at B is more than the pressure at A, right? So this also depends. We know that G is constant, so it doesn't matter. This is the idea that we. So please, stick with this. In case of solids, we have F over A, which is directed downward. In case of liquid, which is directed downward and sides. Okay? Now the third case, we have it here. We have the gases. Gases always kept in a sealed container. مسكرة بالكامل. Just like perfume glasses or something like that. This is a sealed. I'm going to say something in gases. Where's the pressure in gases? It's in all directions. If you figure it out, it's to the sides, down, and up. By the way, Shapir, we say the pressure here at the surface of it, the pressure is equal to 0. I'm talking about the pressure of liquid. Is there any pressure of liquid?
No.
No. So it's 0. But here, no, there's a pressure. Here, there's a pressure. So try to compare. Down and sides, and here in all directions. But one more thing. Always when you remember the gases, remember the word collisions. تصادمات. Collisions of gas particles. What I mean by this word? Gas particles or the pressure here produced by the gas is related to the collisions. That means more collisions, more pressure. I will give you some evidence on that. See, first of all, if we assume this here particle and these particles, you know, gas particles, they are largely spaced, there's some spacing. We say, as an example, this particle collides with this, and with the inner walls also, right? Okay, what happens if we heat the gas? Yes. It's what happens, this energy, thermal energy, it will turn into kinetic energy in the gas particles, and that collision increases, right? And that's why it will reach up to limit. We say that the pressure also increases. I will give you write something. Some of the deodorant, as example, مزيل عرق يا شباب. There is a small tiny mark on it. This means flammable. Can you explain why it's this mark on it? Yes.
We increase the heat of gas will explode.
Yes. Even if it is empty, حتى لو كانت فاضية it contains some air. صح? If you throw it in fire, as an example, what happens?
Explode.
The particles of air, it will explode. The particles of air will gain this energy. The pressure increases. It will expand, intensify. And up to some limit, it will
Explode.
That's why it's necessary to write this sign for it that you make sure that don't ever expose this to fire. لا تعرضها للحريق حتى لو كانت فارغة يا شباب. Okay? This is an idea. Right. So these three states of matter we talk about. Let's talk about something a little bit on the gas particles. You know, for example, when we talk about gases, we concern about atmospheric pressure. This is the Earth. And surround the Earth, there's what we call by the atmosphere. الغلاف الجوي. This atmosphere contains some gases in it, right?
Yes.
Okay. What I say is, the pressure due to the gases or air column above here, it is called by the atmospheric pressure. Suppose if you step on here, إذا أنت واقف هنا يا شباب. This pressure above your head, this is we call by B atmospheric, and we call by B naught. B naught. This stands for atmospheric. Now you know this is natural. It exists everywhere. Every spot in the world contains air. And the air everywhere. ما في مكان في الأرض ما في هواء يا شباب. صح؟ Impossible, you never. So everywhere there is here atmospheric pressure. But what happens when we actually rise up? The air pressure decreases. لما نرفع لفوق ايش يصير؟ And we go down. And this is natural. If we move up like this here to here, the air column will be short or smaller than this one, and vice versa. Okay? Now I need to explain something for you about this one. So the atmospheric pressure is something natural due to the air inside the atmosphere, and it decreases upward, increases downward. Okay? Now I need to tell you something. You heard about something called by the absolute pressure, gauge pressure. You heard about it? طيب انتبهوا معي. See, for the scientists, they measure the atmospheric pressure, which is around 100,000 Pascal. By the way, Pascal is the unit of pressure. We will have some other units today, atmospheric, millimeter, Hg. I will explain for you, but this is simple. And you have to convert it into Pascal. Let me explain this for you. Absolute pressure, I will make just like a scale for you. 0 Pascal. Okay? And we have, this is the atmospheric, B naught, which is 10 to the power 5 Pascal, around, تقريبا. 10 to the power 5 is 100,000 Pascal, okay? 100,000 Pascal. Now what we say, since this pressure, atmosphere, exists everywhere, we don't have to measure it over and over and over. For example, when you measure your patient's blood pressure, you don't have to measure the atmospheric, then the change level. Okay? يعني احنا يا شباب مستحيل يجيك مريضك في غرفة مفرغة من الهواء ما فيها ضغط. كل مكان. فأنت مطلوب منك انك تقيس ضغط دمه مثلا. أنت مش كل مرة راح تقيس الضغط الجوي وتقيس كم زيادة ضغط دمه أو نقصان عن الضغط الجوي. You don't have to do it this way. فلا تبالغ. What we have here, what we do. If we have, for example, someone, his pressure is 120,000 Pascal. 120,000, it will be somewhere here, in this level. This 120 K Pascal. You know what, what's K? Yeah, if you say the absolute pressure, absolute, you start from 0. How much the absolute is 120 K? Right? How much the gauge? The difference. 20 ohm. 20 ohm. And this is very, very important, gentlemen. هذا مهم جدا. This is very easy for us. أنت عندك مريضك، ما في داعي عشان تقيس الضغط الجوي بعدين تقيس الزيادة فوق الضغط. أنت تقيس بس كم؟ الزيادة، بس الزيادة. الضغط الجوي خلاص معروف 100,000. Okay يا شباب? Always this is constant. So if we start from, if we ask for gauge pressure, if we ask for gauge pressure يا شباب, what we do simply, we consider your reference point is the atmospheric. يعني تبدأ من atmospheric هو الصفر تبعك. كم فوق؟ Okay? If we start here, absolute, you start from 0. Again, I want to make something for you. If I say I have pressure which is 90 K Pascal, it's somewhere here, right? Now if you say absolute is 90 K, in gauge it's Allah يسعدكم. Perfect. Yes, minus 10. Minus 10, that means it's below the atmospheric pressure by 10. This is the whole thing. And you know, we deal only with this one. We don't care about this one. Because we don't have a place in any spot in the world that contains 0 pressure. So we concern about this. And again, you know the idea? We don't have to measure the atmospheric pressure over and over and over. مش كل مرة كل يجي مريض استنى خلينا نقيس الضغط الجوي في الغرفة. والله وانت على الدور الرابع خلينا نستنى الضغط الجوي قل. Nothing. It doesn't matter this one. Okay? You only measure the difference. عرفت الفكرة يا شباب؟ So this is the idea. So put this in your mind. I need to. If somebody asks you, there will be some question. Gauge pressure, skip the atmospheric pressure. Just skip it. يعني اعتبره بصفر. Okay? Just like that. طيب. Is that okay for you, شباب?
Yes.
Let's go to the next point about devices we use it for measuring the pressure. Pay attention. You studied with me that there is here a device you use to measure the atmospheric pressure. You know what is the name of this device? جهاز يستخدم قياس الضغط الجوي. No. Yeah? Not thermometer. أيوة, say it. Barometer, not barometer. Okay? طيب يا شباب, you heard about it. Okay, let me explain this for you. We have a barometer. Okay. Barometer is a device used to find or measure P naught. Common this P naught, which is the atmospheric pressure. Okay? What is the idea of this device? This device invented 600 years ago. It's a very simple device. What is it? See, the device simply depends on comparison. مقارنة. If I say, for example, inside this اشتراك, we have different comparisons. Just like, for example, I say my mass is 80 kilogram. In the United States, they say the 80 kilogram, his mass is, for example, 150 pound. His claim is correct. الادعاء صحيح. And my claim is also correct. صح? But I use kilogram as a comparison unit. أنا قارنت كتلتي بالكيلوغرام. هو قارن كتلته بإيش؟ وحتى في عندنا في اللغة العربية في عندنا الرطل، في عندنا أشياء ثانية. يعني it's normal. I can say, for example, what's your name? For example, my mass is 2 Hassan. This is correct. If he's, for example, he's 50 and I'm 100, I say I'm 2 Hassan. I can say your friend is 1.5 Hassan. Your other friend is 2.5 Hassan. We make Hassan as a unit. Is that right? Yes, it's right. We can apply this, by the way. We cannot use this now. Now let me tell you something. Barometer was invented by Torshall. Torshall is a name of scientist. He bring the following. He bring a tank and fill that tank with mercury. Mercury had the following symbol. I will tell you why mercury in precise later. Okay? Fill the tank. And then he bring a tube, a glass tube like this, of length 1 meter. طوله هذا 1 meter. So you can see it is in this size. 1 meter. And he filled it up completely with mercury. ملأه بالكامل mercury. He closed it with his finger, and then he immersed it in the tank. He makes sure there is no air coming inside. كان الحساب ما في ولا هواء يدخل. So what happened when he just simply immersed it like this, it's coming like this, he found that that mercury in the tube, it's actually lower till here, then it stops. Now this is the mercury. Okay?
He has put in the mercury in the tube and
yeah, he just like that, Hisham. See, this is for example, I close the tube, my hand, then I flip it, قلبته, then I just immerse it inside the tank. Okay? I make sure by doing this, there is no air come inside. That's why, what is here now? Tell me.
Nothing.
air.
This is vacuum, فراغ. Nothing. Yes. But we don't care it. But it's not air. Be careful. Okay? Fine. Let us go back to this one. Now, why this stops? Because it's coming equal to something. What is it? Here, I will tell you something. Now, this column of mercury has a pressure at this point. You see, I'll color it for you. Now, this column equals the outside pressure. I will show you something. If you push more, now there is more pressure. What happened to this? Yes, move up. If it is less, move.
No.
Why it stops? Because they become
Equal.
No. Again, I say it here. So let's see. What is here, Ishbak, here? What type of pressure we have here? We have atmospheric only. صح مش مفتوح؟ في عندنا atmospheric. So here we have atmospheric. Here we have this height. We found that height is 76 centimeters. So simply, we say the atmospheric pressure is equal to the pressure of mercury column of height 76 centimeters. That's it. يعني عمود الإشباك الضغط الجوي يعادل ضغط عمود من الزئبق طوله 76 سم. مرة ثانية أنا مرتين زي حسن، أنا مثلا كتلتي 2 حسن، صحيح. Is that right? I'll tell you how we find it. How we find? Oh, we have that pressure of liquid is equal to rho G H. You know that rho of mercury is 13,600. If you use it like this, 13,600 times 9.8 times 0.76. we convert this to meter, you will find it precisely 101,300 Pascal, 101,300. Or we can write it 101.3 kilo. Or sometimes we say it's 10 to the power 5 Pascal, 100,000 Pascal. تقريبا. This will be given for you. Just like a G. G هذا مش 9.8 بيعطوكم اياه، هذا راح يعطوكم اياه دائما. Okay? So again, imagine it. More pressure, this height will increase. Less pressure, this height will decrease. That's simple. So it's comparison. Now I need someone smart to tell me why we use a mercury. Yes.
يمكن كثافته عالية.
Right. Right. Did you know the mercury is the only metal that exists in liquid form?
Yes.
هو فقط المعدن الوحيد موجود يا شباب في حالة سائلة. دون مبالغة إذا مسكتوا قارورة مياه، قارورة مشابهة للميركوري، غالبا لما تمسكها تطيح ايدك من ثلجها. راح أعطيكم مثل simple math هي. For water, raw للwater, how much is it? 1,000.
Yes.
For mercury, it's 13,600.
13,000.
These numbers means mercury is about 13.6 times heavier than water. For this reason, as an example, why we use a mercury? Because if we want to use a water, we need a very large tube like this one, which is inapplicable. غير قادر والله. We will solve this problem. We need around 10 meters of tube. You know 10 meters? This floor has 3 meters. يعني بدنا 3 أدوار ونص، نقول طوله 3 أدوار ونص. It's غير قابل صح؟ وين تمشي فيها 3 أدوار؟ والعمارة. صح؟ لكن هذا this is 1 meter. I told you this is size 1 meter. It's applicable صح؟ This is the idea. So this is it. But by the way, you can use any liquid. Of course, if you use oil, which is less dense than water, we need maybe 12 or 15 meter. It's an idea, okay? So simply, barakallah feek. Ya shabab, simply, we can say atmospheric pressure equals the pressure of liquid column of height 76 centimeter. That's it. Is that all right for you? Right. Now we measure this one. Let's go to the next point. For you in medical applications, I need to tell you something. We say always we use a pressure in Pascal. And Pascal stands for Newton per meter square. For you, sometimes we can give you that. Oh, the pressure in atmospheric. It's simple. 1 atmospheric equals 101,300 Pascal. If I say, hey, what about 1.5 atmospheric equal X, cross product? It's simple. This will be given for you. One more thing, Sinshra. This is very important. For measuring blood pressure, there's a device, an old device, used in all emergency rooms. It depends on mercury. في هذا الجهاز تعرفوه يرفع هيك وتحط ويصير ينفخ فيها. راح ناخذه اليوم. This will give you here the pressure in the following unit in millimeter Hg. This one in millimeter Hg is equal to 760 millimeter, right? In 1 centimeter is 10 millimeter. So you can say 760 millimeter is equal to 101,300 Pascal. Oh, إذا كان مريضك 800 ملم Hg، مريضك يا شباب ضغط دمه 800. You just do this comparison is equal to X Pascal. You do the process. That's it. أنت بس فقط مقارنة. This will be given for you. I'm going to show it to you. These two. So this is the difference here. We are not going to ask about the pound, inch, nothing there. Just atmospheric and millimeter Hg. Which means إذا أعطاكم يا شباب البريشر في atmospheric you have to convert it. إذا أعطاكم فيها millimeter mercury you have to also. أو طبعا لازم باسكال لازم. هذا هو في القوانين لازم نستخدم ايش؟
باسكال.
فتوقع يعطيك هذه او هذه وانت تحول لايش؟ باسكال. اوكي؟ اعملوها simple words. هذا انتم تسموه المقص او الكروس. الواحد اتموسفيريك هذا الرقم، اذا مثلا هذا الرقم يساوي اكس واضربها ببعض وهذا من بهذه الطريقه. اوكي. Is that clear for you?
Yes.
بارك الله فيك. طيب I want to say something before we proceed. لاحظوا يا شباب هاي you always stick with it. خليكم انتبهوا عليها جدا. Liquids, only in liquids, all the points at the same horizontal level they have the same pressure. يعني يا شباب في السوائل كل النقاط التي على نفس المستوى الأفقي لها نفس الضغط بغض النظر. That's why you say the following afterward. This point, this one and two يا شباب they are at the same level. So they have the same pressure. طيب, if I say the following, maybe you took this with Dr. Abdullah or with anybody else. If you have here different, we can say vases. عندكم مزهريات أشكال مختلفة. Just like these. See, you have like these. Any word. See each other. Now they have the same height of liquid in all three. The pressure here, and the pressure here, and the pressure here are the same. Why? I need to clarify this. أوضح لكم إياها. The pressure is coming from the liquid column above the point. من الارتفاع العمودي يا شباب. See, here you can see we have 1, 2, 3, 4, 5, 6, and 7 particles. Here we have also 7 particles. Okay, and here we have the same number. You see? So they have the same, and this means this particle has no pressure on P3. It's away from it. هذا ما بيضغط على P3 يا شباب. اللي بيضغط عليه بس اللي فوق بس. انتبهتوا عليه الفكرة؟ And this one, this particle has no, this one, and this one. So don't care about the shape. You care about the level. This is a tricky question for many students. They use their logic. بيحاولوا يكونوا منطقيين. يعني أو فلسفيين. لأن أنا أذكر قصة بسيطة عشان هذا. أرسطو كان يا شباب فيلسوف، philosopher he was. أعدموه بسبب فلسفته وطاقاته يعني هذا. وهو بينعدم زوجته ووقفت جنبه صارت تبكي. فقال لها ليش تبكي؟ قال ما أنت راح يعدموك وأنت مظلومة. قال يعني لو ما ظلمت ما تبكي؟ قالت الله لا يردك يعدموك. أنت مو تتفلسف يعني. فسيم ثينج يعني. يعني أنت لا تكون زي أرسطو يا شباب. In this way. لا أنت الحين يعني بتفكر في الموت الجيد. This is the idea. Don't please take. يعني أنا ما بدي اللوجيك sometimes very tricky. يعني ممكن أعطيك أشكال أنا مختلفة وهذا وتتوقع هذا أكثر. يعني هذا والله ممتلئة. إحنا ما لنا علاقة ممتلئة. إحنا اللي فوق بس النقطة. صح؟ So be careful. طيب. Tell me, is there any question about this part? Is it okay for you? Very important, by the way. It's called manometer. Manometer is a device. This is used to find the atmospheric pressure. Okay? This is used to find the pressure of any sealed gas or liquid. Simple. I will explain this for you. إيش معنى هذا يا شباب؟ It's actually find the pressure لأي غاز مضغوط أو أي سائل آخر by comparisons. How is it? First of all, the manometer is a U-shaped tube. هو يا شباب التيوب على شكل حرف U. You see how is it? Okay. Pay attention. If we put here liquid in it, بحطينا فيه liquid. The liquid level in two columns will be equal. Suppose we put mercury here. إيش راح يكون liquid? Equal. We have the same thing here. Okay. Now what we do? If we connect this column to gas, pressurized gas, إلى غاز مضغوط زي اسطوانة غاز ربطته هنا يا شباب. ربطته في اسطوانة غاز مضغوطة. Gas. Okay? This gas will apply pressure on this level, it will go down. هذا اللي راح ينزل لتحت يا شباب. And this one will go ممتاز. This will go down and this will go up. Okay. Now to know how much simply the pressure of the gas, you can find the pressure at this point, which is the same as the pressure at this point. It's easy to measure this. إذا نزل هنا 5 سم يا شباب راح يكتب هنا 5 سم. صح؟ إذا التوتال كم كله؟ 10. فأنت بتقول لاحظوا كيف سمبل. والله ضغط الغاز هو ضغط عمود الزئبق طوله كم؟ طيب طول احنا اخذنا هو جي اتش صح؟ فهو بيكون 13,600 times 9.8 times 0.1. خلاص we found it. هذا you can do it at home by the way. You just put the gas here, cylinder with a manometer. Of course you have to use again mercury because it's very dense. Okay? This is an idea. You see, this is comparison. How we compare between, again, points at the same horizontal level. Don't ever use different points. Okay? Now I'm going to give you another example. See, Ishma. Suppose we have a manometer. And in that manometer, we put some different liquids. See, Bob, I will explain. I'll give you 2 or 3 liquids. I will say we have here mercury. Then above the mercury, I'll put another color with it. There's a water. This is water, H2O. And above the water we have oil. By the way, oil is less dense than water. And on the other side of the mercury, we have this side. Let me give you. Now we say this is, say, 5 centimeter. This is 20 centimeter, and this is 30 centimeter. How we find the comparison? Look at this. We find where's 2 points of the same horizontal elevation. This is what we. These 2 points here. You imagine you are self here. 1 and this is 2. Okay? These 2 points have the same pressure. Agree?
Yes.
Same. Right. Pressure 1 is equal to pressure 2. Okay. Pressure 1 is due to the water and oil and also
The atmosphere.
atmospheric. So I'm going to write here, shall I be? P1, P0 for plus rho GH of oil plus rho GH of water. Okay, but equal. This P2, we have atmospheric and we have only 5 centimeter of mercury. Equal B0 plus rho GH of mercury. Okay? They are equivalent. انت الآن والله يا شباب طبعا by the way in this case we skip this one with this one. If it's both here هنا يا شباب no. Here we have to add this one because this is one side only. Here there's no atom, but here we have 2-sided. Is that clear? So they can skip. If you don't know it, you just write and later you can skip it mathematically. يعني الرياضيات إذا كان طرفين يا شباب عندك x هنا وx هنا تقريبا مع بعض صح؟ طيب listen to me. See what will happen. Simply, he will ask for one of these. 6 units you have. You have either how much density of oil or the height of oil is given. How much density of water or the height of water. How much density of mercury or the height of any one could be your actually variable, your unknown. That's it. Always look for, again, same horizontal level, they have the same pressure. عرفت علي بارك الله فيك. This is important. طيب. Now we have some idea. I will give it to you. سهل ومباشر. We say simply, again, pressure 1 is equal to pressure 2. Pressure of oil, this height is equal to the pressure of, for example, water here. Whatever this one. this is how we do the comparison. مرة ثانية كده بنعمل إحنا المقارنة. Let's see now. We talk about this one. We need to solve some problems now. انتبهوا بارك الله فيك. This is simple. At least we need to finish all. What will be the height of a liquid column in a barometer if we use water of density 1000? تعالوا خلينا نحسبها. We know that P is equal to what? Rho G H. The barometer is used to measure the atmospheric. The atmospheric 101 300 Pascal. صح?
Yes.
I need H here. I need H. So simply you can say H is equal to V over rho. You just find it 101 300 over rho. How much is it? 1000 times 9.8. You find that it is 10.2 meter exactly. طول عمود الماء الذي يعاد الضغط الجوي هو 10.2 متر. And I told you why it is inapplicable to find it by using water. We don't have this height of pipes.
Very tall.
Yeah, very tall. 3 or 4 floors. 4 أدوار بتقولوا ما بيكون إيش. So this is the idea يا شباب here. We just put it. I'm sorry, 10.3. Here in mercury, we know how much is it? 760 millimeter, as we said, or 0.76. This is a simple one. Is that okay for you?
Yes.
Let's go to the next point. So this, please, 760 millimeter of mercury, abbreviated by millimeter of G, correspond to pressure of 1 atmospheric. 1 atmospheric, that means 101 300 Pascal. Now we have, this is a very good problem. I will explain it, and I'm going to read it, but it's simple. See, gentlemen, here we have manometer. In this side, we have a water. W stands for water. And this side here, this column is closed. مسكر. We pour some here, oil, in this one. By the way, water, mercury is given, and oil is given. You know the oil is less dense than water. So easily the water will lift oil. Okay? And then it stops at this hand. The height of oil is 75 centimeter. And here, the distance is 25. Follow me. What is actually the idea? What is the gauge pressure? I need to go back to the gauge. So as we say, we find it, and what we do finally, we skip the atmosphere. When the gauge, what we do?
Skip.
Just skip it. نلغيه يا شباب. Okay? طيب. In this case, this is the situation that you have. What is the gauge pressure at the close end? بدنا نعرف يا شباب the close end. Follow me يا شباب. This is the close end. I need it to just to show you something. If you have a movable piston here, إذا كان عندك يا شباب هنا منقص متحرك. If you press more, you'll break this. صح؟
Yes.
So we have a pressure here. وهذا الدليل. The pressure انتقل is simply transfer through the liquid to that level. If you apply more pressure, so this we say there is a pressure here. What we do again to solve this problem, we need to find the pressure here, the gauge pressure. Only gauge, without atmospheric. Let's go to the same horizontal level. صح؟ انتبهوا معي يا شباب. We say B1 is equal to what?
B2.
طيب. What is the pressure above B1? هي انت هنا. ايش اللي يضغط عليك؟ We have rho B naught الأول صح؟ مفتوح plus rho GH of oil. Is that okay?
Yes.
Equals. And the other side, you don't have atmospheric. مسكر هذا.
Water.
صح؟ We have B3 موجود أصلا plus rho GD. I'll write D for this, for water. صح بارك الله فيك. This is simple. هذا إيش اللي فوقها وهذا إيش اللي فوقها. That's very simple thing. What do you do next? Oh, what he asked. What is the gauge pressure of close end? This is the close end. what is the gauge pressure? You can write it يا شباب B3 minus B0 يعني الغي منه اطرح منه الجيج. لما تتعامل معي هنا ليش قلت انت هنا 20 انت كتبت 120 minus 100 صح؟ The same thing you do P3 minus yes what we do simply mathematically you shift this to the other side and shift this to the تعالوا معي we write P3 minus P0 okay this is my gauge pressure this is my gauge equals أرسلنا طبعا احنا الآن هذا هنا وأرسلنا الآن هذا أرسلنا هنا what we say rho G H oil minus إيش بقى rho G H or D بإيش that's it see إيش بقى rho is there H oil is 0.75 rho water is 1000 and H or D water how much is it that's it this is the gauge pressure if he say يا شباب only find the absolute pressure اعملها زي ما هي طلع البي 3 بس ما تعمل ماينس absolute اذا طلب منكم absolute سي يا شباب بي 3 absolute راح تقول لي سهل جدا يساوي بي نوت plus rho g h oil minus rho g h or d للوتر بس اما يا شباب احنا قلنا دائما in case of gauge ايش نسوي في هذه؟ we just skip it. Is that okay for you? بارك الله فيك. واقول لكم حاجه. The key always in these problems this idea. Points at the same horizontal level they have the same pressure. يعني حتى تقارن لازم يكون عندك ايش؟ مفتاح للمقارنه. وين المقارنه؟ نفس الليفل they have the same pressure. واشتغل على ذلك. اوكي؟ بدون مبالغه يا شباب. Sometimes we give you 3 or 4 liquids. أعطيك 4 أو 5 في هنا وهنا ما في مشكلة.
رحمك الله.
فكر في خط واحد horizontal هذه تساوي هذه خلص وكمل عليها اللي فوق. واضحة بارك الله فيكم؟ طيب just 2-3 minutes أو طيب يا شباب this is it. already solved for you. هذا الجواب إذا يعني إن شاء الله تعالى خطوات الماثماتكس أنتم بتحلوها سهلة إن شاء الله. طيب. هنا يا شباب here we have I have a notice on this. I'm done. This is the last point. The SI unit. When I say SI unit, all problems you have to use Pascal. كل المسائل لازم تستخدم باسكال يا شباب. اوكي؟ باسكال. عندنا الباسكال يا شباب يساوي 101.3 كيلو باسكال or 101.300 باسكال. نعرف هذا اللي هو SI unit. We have atmospheric. One atmospheric يساوي هذه. I already told you. We have millimeter of G. وهذه 760 is equal to this one. These just keep it. You're not using inch or not using pounds.
It will not come directly.
No, شوف بس الثلاثة هذول مهمين. توقع إنه ما يعطيك الوحدة بالذات لما تيجي على جهاز البلاد بريشر هذا بيعطيك وحدة ايش؟ مليمتر اتش جي. طبعا هذه فكرته بسيطة جدا very simple. فأنت يا شباب what you do simply you can easily convert it to Pascal. You can easily. Okay? ما نسأل عن users. Okay? طيب الله يعطيكم العافية يا شباب. We stop for today. إن شاء الله